My name is Nurul Amalina bint Abdul Rahman, and my matric number is 175192. And today, me and my group will present our project about mapping. First, I will tell you what is the definition of complex number. Complex number can be expressed in the form of U plus IV, which is U and V are real numbers, and I is the imaginary unit that satisfies the equation of 1 squared equals to -1. And complex number had been used in so many useful applications such as fluid dynamics and electromagnetics. And for this project, we will be using a complex tool which help us to do so many interesting things while learning. And what is complex tool? Complex tool is used to plot the image of domain in complex number under a complex value function.
Hi, my name is Karenisa binti Jaman with matric number 175410. I will continue what my friend have stated earlier. To continue, if any map of the form Fz is equal to Az plus B over Cz plus D, where A, B, C, D are complex numbers, then it is a Mobius transformation. A Mobius transformation are also called as fractional linear transformation or a bilinear transformation. Mobius transformation provides very convenient methods of finding a one-to-one mapping of one domain into another. In this project, we discuss ideas and problems related to Mobius transformation. Mobius maps will send the interior of the domain into the interior of the image. Since M0 is equal to 0, we know that the unit disk gets mapped onto the right half plane W, where real W is larger than -1. The idea of determining the image of domains in C are going to be discussed further on results, and complex tools will help us to visualize the images.
Okay, my name is Muhammad Arifah binti Muhammad. My matric number is 175140. Okay, I will explain about methodology. In our project requires us to find the image of the unit disk, which is mapping Z in modulus Z less than 1 under the map Z over 1 minus Z. To do this, we are use an application of complex tool to plot the image. Okay, we have to include it in this report how to download the complex tool. First, we have to search complex tool in any browser of internet. Okay, after that, we download the zip folder. Okay, after we download the zip folder, we extract complex tool to an appropriate location. Okay, that's all for me. Jason will continue my presentation.
Hey, hello, my name is Jason Menon, matric number 175127. I will do part 2 of the methodology, which is basically what we are supposed to do in the question. I named it mapping. So firstly, obviously you run complex tools, then you type in the function Z over 1 over minus Z, then you select a circular grid, select the range of the radius, and click on the graph until the image appears on the right panel. Basically what you can edit here is the scales may be adjusted to produce a more accurate graph. Here I use -1, and a number of interior circles also you may be edited to produce a cleaner image. You would be able to see this more clearly in the report. These are what we get as for our results. The first image shows you what we get with 9 interior circles, and the second without any interior circles at all, with the range being the same. But what you have to note is here is -11, here is -33. And as for the conclusion, Anis will continue. Thank you.
Hi, my name is Alisahira Miti Ashri. My metric number is 175415. Okay, as the conclusion, as we use Mobius map, it will send the interior of the domain into the interior of the image. Since the Z, which is M0 equal to 0, we know that the unit list gets mapped into the right half of the plane, which is the real W is greater than negative half. So the complex tool is used to plot the image of the domain in C under compact value function. So using the complex tools, we can adjust the image according to the interior circle number and the image range that we want. So from the image that we could see here is the first one is the image using 9 interior circle, and the second image is without the interior circle. So without the interior circle, we can see clearly the image of the function. So that's all from us. Thank you.